All right, now we're going to talk about how to solve quadratic equations using the quadratic formula. All right, so when you solve using completing the square on standard form of the quadratic equation ax squared plus bx plus c, you actually end up with the quadratic formula. So all you have to do is identify what the a, b, and c are in your standard form and just plug them into the quadratic formula. The good thing about the quadratic formula is that it will allow you to solve any quadratic equation. So not everything factors, and not everything can be solved by square rooting, but any quadratic equation can be solved using the quadratic formula. Another important use of the quadratic formula is the piece of the quadratic formula that's actually underneath the radical, which is the b squared minus 4ac. And this has a specific name. It is called the discriminant. And the discriminant will tell you what kind of an answer or roots that you will get. So the discriminant can be positive, it can be negative, or it can be 0. And it'll tell you what kind of answers you have. So if the discriminant is negative, you will have two imaginary solutions. Now, we haven't really talked yet about imaginary solutions, but we'll get to that shortly. If the discriminant is 0, you will have one real solution. And if the discriminant is positive, you will have two real solutions. If it's a perfect square, you'll have two rational solutions. And if it's not a perfect square, you'll have two irrational solutions. Graphically, this is what each one of them will look like. So if the discriminant is negative, then you will have two imaginary solutions. And you can see here that your parabola does not cross the x-axis at all. If the discriminant equals 0, then you will have one real solution, and you can see here that it actually touches the x-axis, so you'll have one solution. And here on the last one, you could have, if the discriminant is greater than 0, you could have two real solutions. They could be rational or irrational. So let's take a look at an example. I'd like you to find the value of the discriminant, describe the nature of the roots, which means tell me is it real, imaginary, rational, irrational, and then solve the equation. So here is your quadratic equation. You can identify your a value. So your a value is what's in front of the x squared term. Your b value is what is in front of the linear term or the x term. And then your c value is the very last one. Your discriminant is b squared minus 4ac. So if you plug these in, you will get 137. Well, 137 is positive, but is not a perfect square, so therefore you know your roots should be two irrational roots. Let's go ahead and solve this and see if that's the case. All right, so if you plug a, b, and c into your quadratic formula, you can see that when you simplify down your radical, you'll have negative 7 plus or minus the square root of 137 over 4. That is indeed two real roots, but they are irrational. Go ahead and put the video on pause and see if you can solve these these 5 equations. Okay, check your answers. Number 1 is negative 9 and 7. Number 2 is 6 and negative 14. 3 is negative 3 and 8. 4 is negative 7 plus or minus the square root of 101 over 2. And 5 is 2 plus or minus 2 square root of 37 over 9. Here's the work of number 1. A value is 1, B is 2, C is negative 3. Plug them in. The square root of 256 is a perfect square. So you have two rational roots. Here's number 2. Again, the square root of 400 is a perfect square, so therefore you have two rational real roots. All right, here you have a is 1, b is -5, c is -24. So you'll end up with 121 underneath the radical, or that is your discriminant, which is a perfect square. So you have two rational real roots, 8 and -3. All right, here's number 4. So now your discriminant ends up being 101, which is not a perfect square. So you still have two real roots, but they are irrational. And here is number 5. So if you have any questions, please let me know.